Need to add validation to an existing tool, but want to keep the original function completely unchanged? You'll see how to wrap a simple addition tool with input validation, using ArgTransform to rename parameters while the validation function checks for positive values, all without modifying the original implementation. The pattern uses forward to pass validated arguments to the underlying tool, keeping the core logic intact. From FastMCP, import FastMCP. From FastMCP tools, import tool. From FastMCP tools, tool transform, import forward. ArgTransform. MCP equals FastMCP. At MCP, tool. Def add x, int y, int. Adds two numbers. Return x plus y. Async def ensure a positive. A, int asterisk quargs, int. If a lesser equals 0. Raise value error. A must be positive. Return await forward. A equals A asterisk quargs. New tool equals tool from tool. Add. Transform fn equals ensure a positive. Transform args equals. X, ArgTransform name equals A. Y, ArgTransform name equals B. MCP, add tool, new tool. This demonstrates the tool transformation pattern, a powerful technique for adapting existing functions into specialized versions without modifying the original implementation. The concept revolves around creating wrapper layers that can rename parameters, add validation, or modify behavior while preserving the core logic. What makes this distinctive is its ability to treat tools as composable building blocks rather than fixed implementations. The pattern works by intercepting calls through a transformation layer that sits between the client and the original function. This layer handles argument mapping, validation, and preprocessing before delegating to the underlying implementation, then optionally post-processes the results. The separation between transformation logic and core functionality enables clean, maintainable adaptations where each concern lives in its own layer. This approach solves the common problem of almost perfect functions that need slight adjustments for different contexts. Instead of duplicating code or creating fragile inheritance chains, you compose transformations that keep the original intact while exposing tailored interfaces. It's particularly valuable when integrating with AI systems, legacy APIs, or when you need to expose simplified versions of complex functions to specific clients. Let's break it down. From FastMCP, import FastMCP. From FastMCP tools, import tool. From FastMCP tools, tool transform, import forward. ArgTransform. Imports the core FastMCP components for building AI callable tools. FastMCP is the main class that bridges Python functions to AI models, while tool and ArgTransform enable function transformation and argument mapping. The forward utility preserves async chaining when wrapping tools. MCP equals FastMCP. Instantiates the core FastMCP controller. This is the central orchestrator that manages all AI callable tools, handles routing, and enforces execution policies. Every FastMCP application starts with this initialization. At MCP, tool. Def add x, int y, int. Adds two numbers. Return x plus y. The @MCP tool decorator registers this function as an AI callable tool. FastMCP converts the type hints and docstring into a schema that AI models use to understand, validate, and invoke the function. This is the standard pattern for exposing Python logic to AI agents. Async def ensure a positive. A, int asterisk quargs, int. If a lesser equals 0. Raise value error. A must be positive. Return await forward. A equals A asterisk quargs. This is an argument validation interceptor. It enforces that parameter A is positive before forwarding the call, preventing invalid inputs from reaching the core logic. The pattern separates validation from business logic, keeping tools clean and predictable.
New tool equals tool from tool. Add.
This creates a new tool by cloning the existing add function. The from tool method preserves the original function's signature and docstring while allowing transformation of its arguments, enabling validation or modification before execution.
MCP, add tool, new tool.
This registers the transformed tool with the FastMCP instance, replacing the original add function. The new version enforces positive input validation while maintaining the same tool interface, demonstrating FastMCP's non-destructive tool modification pattern. Tool transformation pattern. The Transform FN and ArgTransform system lets you intercept, validate, and rename tool arguments without modifying the original function, creating a dynamic contract between client and server. The quargs in your transform function receives renamed arguments after transformation, not the original names, so always use forward, unless you need raw access. This pattern enables backward-compatible API evolution by decoupling the public interface from implementation details.
The argument that changes its name remains the same argument